Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about this problem. So let's get started. Alright, let's see this problem. We are given a problem to find the best time to buy and sell stocks to maximize our profit. So before we move on, I would like to tell one thing that this video is a continuation of the previous video. In previous video, I have already discussed this problem in detail. If you have not watched the previous video, then I highly recommend to watch that video before proceeding to this video. So just to give you an idea, let's have a quick recap of what we did in previous video. So the problem is given as, we are given an array of stock prices of upcoming 6 days. Okay. So here you can see these are the stock prices of 6 days. On day 0, the stock price is $7. On day 1, stock price is 1. On day 2, stock price is 5, so on and so forth. And what was our task? Our task is to do trading, and we have to do trading in such a way that we can make maximum profit out of it. And here we are allowed to make multiple transactions, but we are not allowed to engage in multiple transactions simultaneously. It means we can buy stock on day 1 and sell it on day 2. That is okay. But we cannot buy stock on day 1 and again buy stock on day 2 and sell it on day 3. Okay. So this is the two conditions we should be taking care of while solving this problem. And in previous video, we saw the brute force approach to solve this problem. And in that approach, we have used recursion. So after solving this problem using recursion, the time complexity came out to be big of n square and space complexity came out to be big of n. But we are not satisfied with this time complexity. We can do better. We can solve this problem in constant space and linear time complexity. Moving forward, in this video, we are going to see a solution to solve this problem using iteration. Okay, and this iterative solution is going to solve this problem in big of n time complexity and big of 1 space complexity. So before we move on to the solution or the approach, let's try to analyze this data. These are the data of prices of stocks of 6 days. Do you see any pattern here? Your answer must be a big no. And the reason is simple. Because this data is arranged in a linear order, it's a bit difficult to analyze this data and to find some information out of it. So what happens if we do something so that we can analyze this data in a better way, in an efficient manner? So here we are going to use our best friend mathematics to organize this data and see the pattern out of it. So in mathematics, we all have used graph in the past to represent data. So here also we are going to use graph to organize this data and see the pictorial representation of data, so that it becomes really easy for us to analyze this data and find out some of the properties of this data. So let's do one thing. Let's take all the data from here and plot it on the graph. After we plot all this data on the graph, we could see a graph like this. This is 0.7, 0.1, then 0.5, then 3, then 6 and 4. And all these are the prices of stock. You might be thinking that why I have drawn mountains here. So do you have mountains nearby you? If not, then okay. You can see this picture. These are mountains. Let's analyze these mountains. So when you analyze mountains, you will see two things. One is the peak of the mountains, okay? And this is the highest point of mountains. And other things you can see here is valleys. And these are the lowest point on mountains where rivers flow. Okay. Now could you relate this mountain with this graph? Don't you think this graph also looks like mountains? because if you look at this graph carefully, you will see peaks. These are the peaks, and you will also see valleys, and these 2 points are valleys, right? So I mean to say that when you look at the peak, you see that the stock prices are highest on peaks, and when you see valleys, the stock prices are lowest on peaks. So what does it mean? It means if you somehow find valleys and peaks, you can easily calculate the profit. Let's say here the stock price is 1 and here stock price is 5. So if you subtract 1 from 5, you get a profit of $4. And here on this valley the stock price is $3 and here it is $6. And if you subtract 3 from 6, you get profit of $3. And if you add both the profits, you get profit of $7. Right? So we are done. We just have to find valleys and peak. And that's how we are going to solve this problem. But now the question arises that how to find valleys and peak? Well, answer to this question is pretty simple. We have to simply traverse an array. And if you see the relationship between peak and valley, you can see that if you start traversing from this point, our next point is smaller than this point. So we are going to traverse starting from this point, go till this point, and again we start from this point and go till this point, and again we start from this point and go till this point. Now let me show you how we are going to find valleys and peaks in the given array. So let's say if we would have got data like this. We have 1 point here, 1 point here, 1 point here, and 1 point here. Okay, so this is the highest point, 7, 6, 4, and 1. And we start with this point and we have to find the valley. So how we are going to find valley? So as you can see that if we are at this position, then the next point is smaller than this point because the stock prices are going down, right? So we start from here, we go to the next point, then next point, and in each iteration we check if the next point is lower than the current point or not. And we have to just simply let it go down. And at a moment we reach here. And if stock went up from this point, let's say 2, 3, then at this point, if we calculate that our next point is greater or not, we get false because next point is now greater. So it means this is our valley, correct? And similarly, if you have to found peak, then possibly that this is the peak. Okay, so we start traversing from this point. We see that if the next point is greater or not. So if we found greater, then we simply let this go up, and we simply traverse from 1 to 2, 2 to 3, and 3 to 4. And again, might be possible that we have one downfall here. So when we reach at this point and we check if the next is greater or not, this time it is not. So it means this is our peak. So this is the simple strategy we have to follow to find all the valleys and peaks. And once we get valley and peak, we simply have to subtract valley from peak to get the profit. Okay, so far so clear. Now let's see the implementation of these peak and valley approach. So this is our given array. So we initialized, initially we assume that the first element is our valley and the first element is the peak. And we initialize one more variable, MP, maximum profit, to 0. Okay, now let's see this code. We have a function maximum profit, and this function is taking prices array. Okay, and we are initializing I to 0. We are initializing valley to the first element, peak to the first element, and maximum profit to 0. And we start our loop, and this loop runs from I till price.length minus 1. And why price.length? Because we want to run this loop till this point. We do not want to run this loop till this point, because in each inner loops we are checking ith with I plus 1 item. We will see it in a bit. Okay, and inside this loop we have two inner loops. The first loop is dedicated to find valley, and the second loop is dedicated to find peak. And once we find the peak and valley, we simply subtract it and add the result of this to maximum profit. And after loop gets completed, we simply return maximum profit. And how we are finding valley? We are checking if I is less than price.length, means if we go out of the range, we simply stop the loop. Okay, and price of I is greater than equal to price of I plus 1. Okay, let's say we are at day 0, so we check if the price of day 0 is greater than day 1 or not, and it is. So we simply increment I by 1, right, because we want to find valley. And what happens in case of valley? And we have just saw it that the next element is always smaller than the current element. So this is what we are doing here. And as soon as we get false here, means as soon as this condition becomes false, it means we successfully reach the valley, and we store the price at this index into this variable. Okay, so this is how we are going to find first valley. And in second loop we are going to check if our price is less than price I plus 1. Okay, it means we are checking that this index, price at this index is less than equal to price of this index or not, and we keep moving on like this till we get price less than I plus 1. Okay, and we stop at this position. As soon as we stop, it means we get the first peak, and we store the price at that index into the variable peak, and then we simply have to subtract it. So this is how this function will work. So let's dive into this function and see how it's going to work. So when you call this function, our outer loop begins, and in first iteration it checks if I is less than price.length. This time it is. So our inner loop begins with iteration 1, and this time it begins with I is equal to 0, because we have initialized I to 0. It means we are starting with day 0. So it checks if 7 is greater than 1. Yes, it is. So it increments I by 1, and then it checks, and then in next iteration our I is 1. So price at day 1 is 1. So we check 1 is greater than 5 or not. Now this time 1 is not greater. So we just stop here, and we assign the value of price at index I to our value. It means we find our first value, that is 1. After that our second loop begins. It checks if price at index 1 is less than equal to 5 or not, and this time it is. So it increments the value of I by 1. Now I becomes 2. In next iteration it checks the price at index 2 is 5 is less than equal to 3. It is not. So we just stop here, and it means we find our peak. So we store the price at index 2 into this variable p, and we simply subtract p minus v, means peak minus value, and store it in maximum profit. So till this point both the loops have run successfully, and now it's time to go to next iteration, because we reached till index 2 but we still have more days left, 3, 6 and 5. So we can still have chance to make profit. So this is where our outer loop moves to next iteration, and that is iteration number 2. In this iteration our inner loop begins once again with iteration 1. So it begins with I is equal to 2, and the price at day 2 is 5. It checks if price at day 2 is greater than price at day 3, means 5 is greater than equal to 3. This time it is. So it simply increments I to 3. Okay, and then it checks in next iteration, it checks if the price at index 3 is greater than index 4 or not, and this time it is not. So it means we found the first value again. So we store the price at index 3 to this variable v, and then the next loop begins. And again it checks if price at index 3 is less than equal to price at index 3 plus 1 or not. Means 3 is less than equal to 6. It is true. So it increments the value of I by 1. Now I becomes 4. In next iteration it checks if 6 is less than 4 or not. And this time it is not. So what we have to do, we simply stop this loop and store the price at index 4 to this variable p. So now we have one valley and the price of this value is 3, and we have one peak and the price of this peak is 6. We simply have to do maximum profit is equal to previous maximum profit plus new maximum profit by subtracting 3 from 6. So our total profit comes out to be 7. And in next iteration again our outer loop runs and it checks if 4 is greater than what, because the index goes out of the scope, because it is running till less than price.length, means till index 4, and we have already reached till index 4. So it cannot check I with I plus 1. So that is why our outer loop also gets stopped here and we get our output as 7. So this is how this piece of code is going to run with this data. Okay, so far so clear. I hope you got it. Now talking about the time complexity, we are running 3 loops. First is the outer loop and 2 inner loops. But while running this loop, we never go beyond the scope of this array. It means we never go beyond the index 5. So that is why we can say that we are running loop n times only. So the time complexity of this approach comes out to be big of n. And what about space complexity? As we are not using any extra array other than the prices array and few of the variables to store the data. So we can say that the space complexity of this approach comes out to be big of 1. Or we can say that we are using big of n time and constant space to solve this problem. So this is how we can solve this problem using peak and valley approach. Now before we end this video, let's have a quick recap of what we have done so far. So we are given a problem, and in this problem we are given prices of stocks for 6 days. And our task is to find the best time to buy and sell the stocks so that we can make maximum profit. To solve this problem, we use iterations. And in this approach, we have used the concept of valleys and peaks. And to solve this problem, time complexity came out to be big of n and the space complexity came out to be big of 1. And these two complexities are much better than previous solution. In previous video, we have seen that the time complexity was big of n square and space complexity was big of n. But here we have successfully solved this problem in big of n time complexity and big of 1 space complexity. In upcoming video, we are again going to optimize this code to make it shorter. So make sure you also watch the next video to learn how to optimize this code to make it shorter. Alright, so this is it for this video. Thanks for watching and see you in the next video.